Right? Mrs. Howard's chemistry class, Unit 5, Part 3, electrons in the periodic table again. And let us just continue on. So we're on letter D. Have a piece of candy, gotta spit it out. I know, I can't believe I just did that for all the world to see. Letter D, electrons orbit the nucleus. Okay, electrons orbit the nucleus. How? How do they orbit the nucleus? Well, it's not quite how Bohr said, where it's nice, perfect little orbits like planets orbit the sun. They actually try to explain it with something called the quantum theory, and that uses the fact that electrons act as both particles and waves. And oh, look, there is another video and also a lovely worksheet on orbitals that we'll do in class. Alright, number 1. A quantum, again, we talked about this just with the photons, is the minimum amount of energy that can be gained or lost by an atom. And there's a little dog over here whining next to me, and I'm going to have to go smack it in a minute or tell it to be quiet. Go get Kelly. Don't look at me. So it's the amount of energy that can be gained or lost by an atom, smallest amount. Each type of atom will be slightly different. And the reason for that is that quantum hits the electron, and different atoms have different distances between their orbits of their electrons. So each atom is going to be a little bit different. Now, number 2, a photon is a particle of light, or electromagnetic radiation, with 0 mass, but it carries a little set packet of energy, and all the photons are different. So red photons have different amounts of energy than orange photons. Come here. Then go away. Each one carries a different little amount of energy, so the photons are also different. Number 3, we have something called the Heisenberg uncertainty principle, and that says that you can't determine both the position and the velocity of an electron at the same time, because just by shining light on it and looking at it, you alter where it is. Don't you get to jump up farther away from the nucleus? So just by looking at it, we change where the stuff is. So Heisenberg uncertainty means we can't quite figure out everything about it. Come here. Come here. Come here. Sorry. Okay, number 4. There are 4 quantum numbers that describe the orbits of an electron. Right. The first one is the principal quantum number, and that's written on the periodic table. It tells you the main energy level that's occupied by the electron. If you look down the left-hand side of the periodic table, all the little rows are numbered. 1, 2, 3, 4, 5, 6, 7. So orbit number 1, orbit number 2, orbit number 3, orbit number 4. That's the main energy level that's occupied by that electron. So energy level 1 is the first orbit, and it can hold a maximum of 2 electrons. Energy level number 2, or the second orbit, can hold 8 electrons. Energy level number 3, or the third orbit, can hold up to 18 electrons. And the fourth one can hold up to a maximum of 32 electrons, and so on. The dog left. For the moment, we're safe. Alright, the second of the quantum numbers, is called the angular momentum quantum number, and it's not even a number. It's S, P, D, or F, which, I don't know, they just do this to test me. Angular momentum, and it tells the shape of the orbital. So the S orbital is like a little sphere, the P orbital is almost like a figure 8, and the D orbital looks more like a little flower almost, and then the Z orbital, the F orbital is just kind of a mess. I can't even draw that one. Okay, I can't draw the D one either, but there it is. So the shapes, the angular momentums, quantum number is either an S, a P, a D, or an F. And what's cool about that is that that's also it also shows up on the periodic table. They don't have the letters S, P, D, and F there, but you can put them there, and you can see how the periodic table is broken down to show the S, the P, the D, and the F. The third quantum number is called the magnetic quantum number, and it tells you the orientation of the orbital around the nucleus. Is it along the x-axis, the y-axis, or the z-axis? Okay, the S shape, it's a sphere, so, it's just all in one orientation. The P shape, the P orbital, it's like that figure 8. It can be along the y-axis, along the x-axis, sideways, or, I don't know how to do this one, along the z-axis. Ooh, 3D. I need 3D! then you can see my finger coming into your face right here. Okay, the D shape has 5 different sublevels and it can hold 10 electrons. I wouldn't even begin to try and figure out how that looks. So go back up to the S shape. It has 1 orientation. It can hold 2 electrons. The P shape has 3 different sublevels and it can hold a total of 6 electrons, 2 in each orientation. So it can hold 2 in this one, 2 in this one, and 2 in this one. Whew, that's kind of cool. The D shape has 5 different ones, can hold 10. And the F shape has 7 different ones, and it can hold 14 electrons in there. Oh, look at that SPDF. So you look at the periodic table, and you look at that first column over there, and the last electron you stick into any of those orbits will be in an S orbital in those 2 columns right there. The P's over on the right-hand side, the P orbitals, the last electron you stick into any of those will be in a P orbital. Oh my gosh. The transition metals, little short group in the center, the last electron you stick in there will be in a D orbital. And then look down at the bottom, the pulled-out section. You know, they mainly pulled it out just so it'll fit on a page. But strangely enough, it also makes sense because the last electron you stick into that section will be in an F orbital. So it's kind of freakish like that. So you have the S, the P, the D, and the F. Now, you have the 4th and last of the quantum numbers. So we had the first quantum number that told you what orbit it's in, 1, 2, 3, 4, 5, 6, or 7. You had the second quantum number, which told you whether it was an S, a P, a D, or an F. You had the third quantum number, which, let me backtrack here and show you what I'm talking about. The third quantum number is the magnetic quantum number, and it tells you the orientation. Is it along the x-axis, the y-axis, or the z-axis? And then the 4th one is called the spin quantum number, and they usually indicate this with an up arrow or a down arrow, which basically tells you is the electron spinning one direction or another, clockwise or counterclockwise, if you want to use that. Oh my gosh, there's another video, quantum mechanics for the MPV generation. We'll see all these in class. Oh, and it ends here.